Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem Pascal's triangle, which is a standard problem. In this problem, we are given an integer nums rows, which represents the first nums rows of Pascal's triangle, and we have to return first nums rows of this Pascal's triangle. So what is a Pascal's triangle? A Pascal's triangle is basically a triangle of numbers in which each number is the sum of two numbers directly above it. So let's understand the exemplar test case. The input will be an integer, and in the output we have to return a two-dimensional matrix representing the Pascal's triangle. The constraints of the problems are that the number of rows that we can generate can go up to 30. Let's understand Pascal triangle in more detail. So in this input test case, we're given 5 and we have to return first 5 rows of the Pascal's triangle. So here are first 5 rows. First row contains 1. The second row again contains 1 and 1 because the number of elements just above this row is less than 1. Hence, we cannot add one element. We need at least 3 elements to generate a new number. In the third row, we write 1, then we write the sum of this one and this one, that is, and then finally we write 1. In the next row, we have 1, then the sum of these two numbers, that is 1 plus 2, it is 3, then 2 plus 1, it is 3, then finally 1. Then in the fifth row, we start with 1, we write the sum of 1 and 3, that is 4, sum of 3 and 3, that is 6, sum of 3 and 1, that is 4, and finally we write 1. So this is a Pascal's triangle for 5 rows. Okay, let's see how we can generate this triangle using, so this is how you imagine this triangle in a two-dimensional matrix. So if we want to generate 5 rows, then we declare a matrix of dimensions 5 cross 5, 5 rows and 5 columns, and we can observe that each row, this is the first row, it contains one element. This is the second row, it contains 2 elements. This is third row and it contains 3 elements. The number of elements in each row is equal to the row number itself, and that will give us the solution to this problem. We can also observe that the pattern that present in this Pascal's triangle is similar to the pattern here. That means in the first row we have to calculate the binomial coefficient. So NCR represents the binomial coefficient, that is the number of ways to select R from N. And in the first row we have 0C0, then in the second row we have 1C0, 1C1, and in the third row we 2C0, 2C1, 2C2, and so on. So this pattern is similar to this pattern. So we'll understand how this will help us to solve the follow-ups of this Pascal's triangle. So all we have to do is to traverse over the rows, and for each row iterate over the columns, and the number of columns, the number of integers that will be generated for each row will be equal to the row number itself. So that will give me, okay, so all we have to do is we are traversing this row, let's say, and initially we start from this column, that is first column, and here you can see we cannot sum the numbers above it because there is no number which is present here. Hence we move to next column here, and 2 is basically the sum of 1 and 1, and this one we copy from here. Then we start by putting 1 here, and then we see, okay, 3 is sum of 1 and 2, and this 3 is sum of this 2 and this, and finally we put 2. So each row starts with a 1, ends with a 1, while the elements which are in between those ones are basically the sums of 2 elements that are above them. So let's see how we can implement this in code. So this is the implementation. This is a Pascal's triangle. This is a function which generates a Pascal's triangle and return, and it takes in an integer n, which represents the number of rows which must be present in the Pascal's triangle. So we declare an array of dimensions n cross n. So this array is basically, here we run a loop that runs from 0 to n-1, representing the indices of each row, and for each row we add a vector of size I plus 1. So if it is a first row, we add a vector of size 1. If it is a second row, we add a vector of size 2. A vector is basically a dynamic array. This basically will generate a pattern of this type. First array of size 1, second array of size 2, and so on. And it will reduce the space complexity for the code. Hence, we are using this type of configuration where we have two-dimensional array. We are assigning 1 to the first position and in the last position. Then we start from the second column and go up until the second last column. The last column is ith column because for ith row I have I number of, and this is the relationship, that is the number in a cell ij is basically the sum of the number present in the previous row and a column just left to jth column, that is j minus 1th column, plus the previous row and the column j. That's the relationship which will generate the Pascal's triangle. And finally we return the Pascal triangle right from here. Let's discuss the time complexity for this solution. Time complexity is quadratic time complexity, that is we are running a loop. This loop runs n times and this loop also runs n times in the worst. Hence the time complexity becomes n square, where n represents the number of rows in the Pascal's triangle, while the space complexity is also n square because we are using a matrix of dimensions n cross. Obviously the space is little less than this. Let's see a follow-up for Pascal's triangle. So in case we are asked that you're given a row number and a column number, return the element that is present at that location represented by that row and column in linear time complexity. How would you do that? In that case, the pattern that we identified here will help. All the numbers in the Pascal's triangle are basically the binomial coefficients if n represents the row. So for any, let's say, kth row, we want to find the, let's say, jth element, then all we have to do is to calculate this number where k represents the row number, j represents the column number. So let's say I want to calculate this. I will find what is the row number for this element. It is 2. What is the column number for this element? It is 1. So column number is 1. So all we have to do is to calculate 2c1, that is number of ways to select 1. That's how we find any element in a Pascal's triangle. Then another follow-up is find a particular row for a Pascal's triangle. For that, all we have to do is just find which row we want to generate. So let's say I want to generate row number 3. So I will iterate for, let's say I want to generate row number 4, that is this is row number. So I will run a loop 4 times and starting from 0 to 3, and for each integer representing, so I will run a loop from 0 to 3 and calculate nci, where I is my iterator which is iterating over the columns. Okay, so this is I. So I is 0 here, so I will calculate 3c0 which is 1. I is 1 here, so I will calculate 3c1, that is 3. I is 2 here, so I will calculate 3c2, that is 3. I is 3 here, so I will calculate 3c3 which is same as 3c0, hence 1. That's how I generate a particular row in a Pascal's triangle. So here we can sum up the problem. Each element that is present in nth row and mth column in a Pascal's triangle is computed by the sum of elements present in the previous row and a column with each element present in nth row and mth column in a Pascal's triangle is computed by the sum of elements present in n-1th row and m-1th column and mth column. So this is the function for generating a Pascal's triangle. So in this function returns a vector. It returns our Pascal's triangle. Since it is returning a two-dimensional array, we will declare a two-dimensional array of size n, where n represents the number of rows, and hence we have to declare a two-dimensional array of size n. We iterate over each row, so we have n rows. We iterating over each row. For each row, I am resizing the array that I declared. That is, for ith row, I require an array of size I plus 1. Then I will assign 1 to the first and last location of this array. Then I will iterate over each column and calculate my integer that is present in ith row and jth column. Finally, I return my array right from here. So this is a implementation in Java language, and this is implementation in Python language. That's all for this video. I have attached the code in the description. Make sure to check it out and stay tuned for more such